K. Prakash, working as an assistant professor in the Department of Mechanical Engineering, SNS College of Technology. So in the previous video we have discussed about the performance test in IC engines. So today we are going to discuss about the heat balance sheet in the IC engines. So before going to the topic, let us discuss what is performance test and what is heat balance sheet. So in the performance test we are finding the output. We are finding the mechanical efficiency and thermal efficiency of an IC engine. Here in the heat balance sheet we are having a relationship between the input and the output. So here what is the input and what is the output? Okay. So here first let us discuss about the input. So basically fuel is used to run this IC engine. So basically this is a diesel engine. So fuel used here is diesel. So it has chemical energy. So this is converted into mechanical energy. So the output is mechanical energy, whereas the input is chemical energy. So in intermediate between this, the heat energy plays a very important role, because the chemical energy is converted into heat energy. So the amount of heat energy utilized plays a vital role in the output of this machine. That is called as the efficiency. So how the heat is dissipated and what is the heat input? So here, before going to the concept, we must understand that how to calculate the input, heat energy. So here, the fuel used is having a calorific value. So what is calorific value is the amount of heat liberated by burning completely 1 kilogram of fuel is called as calorific value. So based on this calorific value and the amount of the fuel utilized, the input heat energy can be calculated, and the amount of heat energy produced inside this cylinder is converted into different forms. So initially the maximum amount of the heat energy is converted into converting in the brake power. So there is a piston and a connecting rod on that crankshaft. So the heat energy mostly is utilized to convert into brake power. And next, here in an engine, what happens is radiator is there for purpose of cooling, because excessive cooling will take place the wear and tear of the parts. So to avoid this, we are having a cooling system. So the inlet water at room temperature, which is coming inside, what happens is takes away the heat. So this way the heat is dissipated by the cooling water. Next, coming to the exhaust. So this black color is the exhaust. So basically air is needed to burn. For complete combustion we are using the air and the fuel. So this exhaust energy is taking place more amount of heat energy. So some amount of heat is dissipated through this exhaust. And if you take this engine, it is made of many number of parts. So as this is a metal based on the conduction. So what is meant by conduction is heat is transferred from one place to another in the same medium. So the heat produced is absorbed by these parts. So this heat absorbed by these parts cannot be identified. And then if you take the process of convection, the air which is having a contact with this engine takes away some heat. So this we cannot find accurately. So here what we are doing is, so the input heat energy produced is calculated, and then the exhaust is taken, a heat balance sheet is drawn. So total amount of heat energy produced and then the amount of heat energy spent in the form of kilojoules per kilogram. So here the amount taken for the conversion of heat into brake power, and then the heat taken away by the cooling water, and then the heat taken away by the exhaust gas. So from the total heat power produced, these three are added and subtracted from the total. So the remaining amount of heat energy lost is taken as unaccounted losses. What is the unaccounted losses here is the heat absorbed by these parts and then the heat taken away by the air. So here in the heat balance sheet, so we are making a tally between the input energy and the output. So input is the heat, and how much heat, that is 100% produced is 100%. For example, it may be some 100 kilojoules, for example I am saying. So this 100 kilojoules have to be utilized here, whereas some 35% or 40% is utilized for the production of brake power. So some 10 to 20% may be taken away by the cooling water, some 20% will be taken away by the exhaust gas, and then some 5 to 10% may be 5% may be unaccounted losses. So based on this input and output, we are making a table based on the heat. So that is called as heat balance sheet. So this test can be conducted based on an IC engines, whether it is a diesel power or whether it is a petrol engine. So I am coming to the heat balance sheet. So here we can do this heat balance sheet and we can find out effectively how much amount of heat energy is produced or utilized for work done. Okay. So this is the heat energy. In the next video we will discuss how to do a heat balance test in a IC engine. Thank you.